We are looking over lesson 3.6 to make sure we can pull out the major details that you'll be held accountable for. We're proving angle relationships here. So with our angle relationships, these are very similar to the segment relationships that we've seen already. So we can look, we have the protractor postulate, which is like the ruler postulate, is that you can measure anything. And mainly is that we're looking between angles from 0 and 180 degrees. Angle addition postulate is like the segment addition postulate, where if you add up the two on the inside, you get the total on the outside. The supplement theorem, if two angles form a linear pair, they're supplementary. Linear pair, that means they're on the same line. Supplementary, they add up to be 180 degrees. Complement theorem, two non-common sides of two adjacent angles form a right angle. Then the angles are complementary. Remember, complementary and right angle, they add to be 90 degrees. Then we have some examples here. Congruent supplements theorem. Angles supplementary to the same angle or to congruent angles are congruent. So we're just looking at the fact that some of these angles are congruent. So we have the supplemental right here, the fact that angle 1 plus angle 2, it looks like they're on a line. That means they form 180 degrees. Angle 2 and angle 3, those look like they're on a line. They form like a line. That means they're supplemental. They add up to be 180 degrees also. That just means that angle 1 and angle 3 have to be the same. It's like you're subtracting angle 2 from it. So that's how you know they're equal. So it's just kind of a way of skipping a step. Congruent complements theorem, it's going to be the same idea, but with the fact of 90 degrees as your focus. So angle 4 plus angle 5, if those equal 90. Angle 5 and angle 6, if those equal 90, it's like if you take 5 out of the way, if you subtract 5 off of both of them, then angle 4 would equal angle 6. And here's the big one, vertical angles. Vertical angles are across from each other. So 1 matches 3, they're the same. 2 matches 4, and they're the same. And that's all that's saying down there. And we're just looking over some examples here. Vertical angle examples, right angle theorems, perpendicular lines intersect to form 4 right angles. That's correct. So we can just kind of look at the example there if we wanted to draw it. And that would be like these are right angles. So all of these, if these are perpendicular lines, and all of these are right angles. All right angles are congruent. They're all 90 degrees. That means they're all the same. Perpendicular lines form congruent adjacent angles. So adjacent means they're next to. So 2 is next to 1, 1 is next to 4, 4 is next to 3, 3 is next to 2. So if they share a side, that means they're adjacent and they're equal or congruent. If two angles are congruent and supplementary, then each angle is a right angle. So it's the idea that congruent and supplementary. So if they add to be 180 degrees and they're complementary, that means they're both 90. They add to be 180. If two congruent angles form a linear pair, then they are right angles. Congruent, they're the same. They form a linear pair. They're on a line. The only way you can have the same on a line is if they're both 90 or right angles. And just looking through and going through some of the examples here. And then that's all we have for section 3.6.